Good morning. It's CS264, lecture 7, 5 past 11, and we'll start and we'll work over the next hour on software design using C#. Thank you for attending the lecture. So let's go straight to the slides and we can see what we're going to be working on today. So today's lecture then is going to mostly focus on advanced C# concepts. We're going to look at generics, we're going to look at indexers. Link is part of this week's module, so we won't get to it today because there's a lot to cover. So we'll do that in the lessons separately, but this is the topic for the week. And I'll cover a good bit of it this morning. So we're going to visit some of the advanced features of C# in particular. Some of these concepts, of course, you will have seen before. Some of them may not be too advanced for you as well. But, you know, I guess there'll be something in there that will give you something interesting to think about and think, well, that's a cool feature. I didn't see that before. Perhaps I could use it in my assignments or in my work. So, and that's the point of this. You've done a lot of the OO work with Java previously, and you've done a lot of work with data modeling and data processing with JavaScript and Python and lots of other things. And I guess with your second year modules on data structures and algorithms, you know a lot about the built-in data structures like lists and hash tables and queues and stacks. And we see those near the end of this particular class today. I've written some programs for you, and I have a bunch of demos that I've taken from the Microsoft website as well, and maybe made a few small changes to those, and I'll work through those live with you as well. So if you have any questions at all, just put them into the chat, and I'll try to address them as we work through the lecture. Okay, so I think there seems to be a problem with this display currently, so just let me just check. Yeah, that's a little bit better. I think my display had moved a little bit, so I want to bring it down here. So I think that's a little bit better now. Okay, so I think that looks a little bit better now. Okay, so right, so we're going to discuss the advanced, and of course, they're not just there because they're advanced, and you know they're useful features of the C# programming language. So we'll look at indexers, collections, and generics specifically in this particular class today, and we'll look at link language integrated query in the next set of lectures. So let's look at these three main advanced topics that we'll work with today. And if you go to any tutorial on C#, you'll see these, Microsoft or any of your favorite places to go online. They'll talk about indexers, collections, and generics. Okay, so what are these? So indexers allow an object to be indexed like an array. That means when you define an indexer for a class, the class behaves like a virtual array. That means you can access instances of the class using your square brackets operator. And it's nice to be able to do that. Collections then, these are collection classes, and they're very specialized collections that you have for managing data storage and retrieval. So there's support internally in C# for stacks, queues, lists, bit arrays, hash tables. There's a sorted list as well, there's a few others, okay? And these basic or fundamental collection classes, they create collections of objects, and they're of type object, okay? Which is the base type in C#, of course. And you will have seen these data structures in your second year modules already. So you know what a queue is, and you probably have written how to build a queue in Java. You may have used some internal features for this. And of course, if you need to use a queue, or you need to use a list or something in your program, or hash table in your application, then it's always advised to write your own. Sorry, not to write your own. It's always advised to write your own once, okay? I'm just getting a bit distracted there. Write once, and then when you've figured out how to do it, use the internal version because it's probably much more efficient than yours anyway, and it's optimized for that particular application programming language. So that's collections, okay? We use them all the time in JavaScript as well, of course. So generics then, they facilitate the deferred definition of the specification of classes and methods of one or more types until the class or method is declared and instantiated by the client code. Now that's a that's a proper definition, it's but it's quite succinct, and it's unambiguous. And really what it does is it tells us that it allows the development of a class or method that can work with any data type. And they're beautiful, and it's nice, and it's worthwhile getting to know those. And you'll see actually that when we look at the notes as we work through this particular set of lectures and slides, we'll deal with generics before we deal with collections, because the collections tend to work with they are generic classes. So we'll see a little bit about that as we work through. Okay. So now let's move on to some basics. Okay. So before we do any kinds of advanced stuff, we actually have to be sure that we understand our basics. So arrays are core. They're our core data structure in C#. So when we think about collections, the kind of collection that we've experienced up until now are arrays, okay? And they allow us to be able to aggregate or bundle together lots of variables, that are referenced using a single name, and they are indexed. So the thing about arrays is that they're ordered. You know where the first element is, you know where the second element is. And you know how big the element is, how big the array is. Okay? And that's useful. Okay, so they store fixed numbers of literal values. Okay? So in C#, they can be single dimensional, multi-dimensional, or jagged. And I guess in some respects, when I think a little bit about the advanced bit, I'm thinking in terms of the whole notion of jagged or multi-dimensional arrays. You may not have seen these already. Okay, so here's a very straightforward program that deals with some of these declarations. So our basic declaration of an array, we can create it using square brackets. We can create ints and strings, for example, and we can have an initialization here, of course, by using these chain operators, this list. And we can do that for ints. Say we could actually replace the semicolon here with is assign the value of new int 4 and just initialize every element of the array at the time of creation. We could do the same for strings. We could actually create some names, and we could add this list of strings here as well. So it's fairly straightforward to do. That's one way to declare an array. Another way is where we don't actually have, you'll see here with the int, we have our square brackets on the basic type, or we could just use var. And if we use var, then we don't actually have to use the square brackets at that point here as part of the declaration of that type. Okay, and we saw var in some recent lectures as well. So we could have a sequence of numbers, var sequence of numbers, int 1, 2, 3, 4, and it knows that the type is int, or it can infer the type is int from this and from the literal values here. We could create a string called Brontes, new string, and again Charlotte, Elizabeth, Anne, and Maria. So we could do this as well. Another thing to remember, of course, is that there's no size required at the declaration time as well. We could ignore the 4s here, and it could be obvious how many are in this particular set here. And so we could have some primes, and we could have a string array called sisters. We could also have this late initialization, as we've seen before. We mentioned up here where we could just define these numbers here. Define the declaration of the variable here, and then later we can actually do the initialization and do it. It doesn't have to be part of the declaration. And then, of course, if we want to iterate, it should be iteration, not alliteration here. We just iterate using a loop, and we can, print the numbers and print the strings. Okay, so it's a fairly straightforward exercise. I have a demo here, so I can just probably go and have a quick peek just to make sure everything works okay. So let's see if I can switch to so let's have a look at where I am now. Okay, so here we are. Let's go to lecture. We'll have a look here, and we can make this one a little bit different as well. Yeah, I think that's okay. Let's have a look at this. Let's just move that slightly there, so you should be able to see it a little bit better. Okay. Okay, so we're interested in, there's something called my arrays there. So let's see the, okay, and I have an example program. This example program is here. It's not really too different from what we had earlier. And we can see that's running. I also have produced some multi-dimensional arrays. So let's go back to Keynote and see about that. So we can look at everything in the one program running. Okay. So we can produce these multi-dimensional arrays as well. And they can be declared by adding commas inside the square bracket. So for example, bracket, comma, bracket declares a two-dimensional array, and bracket, comma, comma, bracket declares a three-dimensional array, etc., etc., etc. I think you could have up to 32 dimensions of arrays in C#. And you may have occasion to do that, of course, you know. So that's a multi-dimensional one. A jagged array, that's an array of arrays. And jagged arrays store arrays instead of literal values. And then those stored arrays contain literal values. Or maybe they're jagged as well and to contain arrays too. Depends on the initialization. So a two-dimensional, for example, jagged array could be done with bracket, bracket. And so this is different from the bracket, comma, bracket. Okay, and we can work from there. Okay, so the second bracket specifies the dimensions of the array that's going to be stored. So, and I see a question there, and I'll get to that. This question on efficiency as soon as I finish this slide. Thank you for asking. So here's a matrix, for example. We've created this matrix. It's a two-dimensional one. You can see it's an array of arrays, and it's just a two-dimensional matrix. Okay, and you know it's ints. Okay, here is a multi-dimensional as well. So this is, for example, it's like a table. So here we have a list of columns. So again, it's two-dimensional, and it's 4, 2. Okay, here 1, 2, 3, 4, and it's fine. Here we didn't specify the actual size, but it's obvious, and we can write out the literal value at that point or place in the array. Okay, so our jagged arrays then are different. Okay, you can see we have a jagged array here. So we have a two-dimensional jagged array that has 3 rows. Okay, and each of them contains an array. And so here's the array for the first row, second row, third row, and we can just access them this way. So the issue, I guess, the difference here is we're looking at these square bracket sets as opposed to a square bracket separated by commas to index. Okay, and this will generate an error, of course, this line here, because we don't actually have a position 2. Sorry, we don't have a position 1 in this particular line or element of this particular array. Okay, so that's a little bit about those. Okay, so somebody asked a question of which is more efficient, arrays or array lists. So the array lists will allow you to be able to set up and have a list and manage your data structure as it works, essentially as a list, and also allow you to index that. So it allows you to index on top of this. So it has a lot of work, extra work to do, but it gives you all that extra flexibility. So and the flex. So I suppose efficiency is fine. So if you have a fixed collection of objects, so if you know how many objects that you're going to have in that collection, then an array is going to be always more efficient, and you can iterate over that array, and because you can get the next one, you can do a for each loop or a for loop, and that's fine. But you can also do this with an array list. The difference, of course, is that you can continue to add more and more and more elements to the array list. So you may or may not know how many are going to be in that list at the time. Okay, I hope that answers it. So the efficiency is a good issue, but sometimes it's more about flexibility in terms of making a choice between the two of them rather than efficiency. But it's a good question, and thanks for asking, and you're welcome. Okay, let's go back to the program then, and just see all of those working, just to be sure. And as I've mentioned to you before, all of these will be available for you to look at and play with yourself. Okay, so that's the program. It's no different really. I just copied all the stuff in here. I created it. You can paste them and so forth and see how it works. So And so what's happening here, I guess, is that we get the outputs for the first ones, which we expected, 1, 2, 3, 4, Charlotte, Elizabeth, the Brontes. Then we were able to access that. And we found we got this unhandled exception. So there was an index out of range. And we expected to get that error at the end of our program because we couldn't access this. It's a jagged array. It's not square. Okay, so triangular arrays. And you can do this in JavaScript as well. I mean, I like triangular arrays. In fact, you can do this in Java too. Okay, so and jagged, I always refer to them as triangular in a way, but jagged is better because if you're looking at multi-dimensions, you don't have multi-dimensional triangles. Triangles just 2D, so it's fine. Okay, so that's kind of a little bit about our data structures. And the reason I guess I wanted to do arrays and wanted to talk about these structures, and it prompted you thinking about that question, is the main reason is I want to be able to see, well, how do we deal with data structures where we have and options for managing data structures where we have flexible lists of numbers, or we don't know the numbers in advance. So something else I want to tell you about that I find really interesting are called struts. Let me get some coffee. So I don't know if you've seen these yet, but I really like them, they're deadly. Okay, so a structure type, and they're called struts, and they're a value type that can encapsulate data and related functionality. So you can use the struct keyword then to define a structure type. So structure types have these value semantics associated with them. That means that a variable of a structure type contains an instance of the type. So by default, variable values are copied on assignment, passing an argument to a method and returning a method result. So in the case of a structure type variable, an instance of the type is copied. So that's again the formal stuff. So typically, and we'll see an example in a few minutes, okay? Typically, you use structure types to define small data-centric types that provide little or no behavior. And that's really interesting because the kind of work that you've been doing up until now, we've been getting you to think about classes, and classes have both structure and behavior. But let's say the behavior is minimal or pretty much non-existent. So then why would you waste and have all this overhead of a class when you could have some kind of simpler data structure? So this is why we have structs in the first place. So if you're focused on the behavior of the type, then consider defining a class. So if you have no behavior at all, very little behavior, then you can actually use a struct. Okay, and they behave very similar to classes, of course. So structure types have these value semantics, and Microsoft recommends that you define immutable structure types, so it can't be changed. So so what's this value semantics thing? So in computer science, and you may have seen this already, of course, in your other classes, having value semantics or value type semantics or copy by value semantics means that for an object, only its value counts, not its identity. Okay? Only the value counts, not the identity. If the concept is fully applied, then value semantics implies immutability of the object, and an immutable object is defined as an object that can't be changed after it's been created. So that kind of makes sense, that makes sense. If you want to have a look at information on structs, I've put in a link here to the Microsoft.NET documentation. You can just click through and you'll find information on that there. Okay. But I also have demos for you. Okay, so demos are always cool. Okay, so we can use the read-only keywords to make a struct immutable, and structs can include constructors, constants, fields, methods, properties, indexers, operators, events, nested types. It cannot include a parameterless constructor or a destructor. Okay, we haven't really talked about destructors, but they exist as well. Again, you don't see them in Java. Okay, well, you probably didn't see them in Java. Okay, so and structs can implement interfaces. They can't inherit another structure or a class. They can't be the base of a class, so you can't subclass them essentially. So and struct members can't be specified as abstract, sealed, virtual, or protected. You've seen all of these terms already, so it's good. Let's have a look at one. Okay, so here's a nice example here. So here, for example, is a struct for a point. So you may have done this kind of thing for classes. Okay, with classes. But a point really is just a point if we're doing for graphics or some graphics type application. And points are, they're pretty much uninteresting. Why would you have a class for a point? Because it doesn't really have any behavior. It just exists and is there, and we know where it is, and that's it. So it's good for us to be able to do that. And we might have a point, and we can move that point around in space. So that's that's kind of a useful exercise to have. So really, I would think then that here we have one. So we have a public struct point, okay, and we could have actually said public read-only struct point as well if we wanted. And then we have a constructor, and remember, it's not parameterless; it has to have parameters. So public point double x double y, and we have some getters and setters, and here's some methods. So essentially we have, and we're setting up our getters and setters as properties, but there's no setters in this particular case, it's just a getter, okay? And it tells us what the point is. So once it's created, we don't want to really change it, okay? We could actually have a method too, okay? And we could set the origin, so we could actually say point, we create a point, and then we can just set the origin. And then we have a string then that allows us to be, we're overriding we're overriding the toString method for this particular struct, and we're going to print out the x and y value in brackets, so it looks like a point. Notice this arrow here. This is an expression body definition, and you've seen this kind of thing in JavaScript as well. Okay, so when we did a lot of Node.js stuff, we saw that. So it works in much the same way again. Okay, you could have a look at that if you wanted. If you look up expression body definition, for example, you should be good to define the information for examples of that. So basically, it returns an expression. So it's nice, and we tend to see this where you have methods, or where you're defining methods that just have a single return value, okay, or with some getters, okay. So just before I move on, okay, Brian, that was a question again, and sorry if I wasn't clear about this. So the advantage, and the question is, what would be the advantage of using like a struct instead of a regular class? So struct will be much more efficient, So you remember that classes and if you have something like classes and creating objects, and you have an original, all classes will in some way inherit from the object class, then the programming language has to do an awful lot of work to set up all of that structure for you in place, okay, and for you to be able to do this. So generally, and because a lot of it has to be done with behaviors, it has to check for methods, it has to check for overriding, it has to check for overloading, it has all this work to do, okay. But sometimes you just want something a little bit more simple. You just want to be able to aggregate and produce aggregate data types, that just have an existence, but they don't have too much behavior. All we want to do with them is to be able to add and stuff. So again, if you come back to the question that we had earlier about efficiency, okay, and this is where the question, like Philo asked this question earlier, it could be said, which is more efficient, classes or struts? Then, I would say it depends again, structs are going to be much more efficient because, they're simpler. The compiler doesn't have to do as much work. Does that help? I hope that helps. Okay, and if not, you can come back to me. Okay, let's have a look at the example for this. I'm sure. I think I was fairly unimaginative with all of my thing. I have my structs here as well. Let's have a look at this one. Okay, and let's. Okay, so here is a demo program, my structs, and I've created this point struct. And you have an assignment coming up, where you're dealing with shapes and shapes at points and so forth. Well, you might be thinking about, well, I could use points or coordinate systems around this, something similar. So here I have some properties created, capital X and capital Y, and that gives us returns these values here. And we have a method just to set the origin if we wanted. So it's pretty much the same. So now let's have a look at the example code, the executable code, the test code. So create a point P1, that's point 1010, point 2, 2020, and we can write out P1.x, P1.y, P1, just to get, there are lots of ways of accessing the information here. We could assign the value of point 1 to point 2. Let's have a look at what happens there, and then print these and see what happens. Okay, and let's run it. See, do we get the outputs we expect? Always good to do this. Okay. So we have our point 1, was 10, 10. We printed this. X and Y, we got 10 and 10. That was expected. Print out point 1, 10, 10. Print out point 2, 10, 10. Oh, sorry, 2020. Point 1 is now assigned a value of 0.2. So this allows us to be able to do all of this stuff. Let's get rid of this. Override and let's call the method, because we can do that with these structs as well. Run it again. Doesn't set. That's because I had this. Now let's do this. Nothing wrong with having errors. Oh God, more errors. Okay. There's a surprise. Okay. So we can't do this. So there's lots of rules that we had and mentioned. Okay. Because it's read only. Okay. So let's have a peek. So we can change those if we want and go back again. So I want you to be able to have a look at some of these and understand why we would get errors. Okay. So this is why we use the names here rather than our set origin here. Okay, as values. Okay, so you need to be able to think a little bit about why we would do this, and why we might not do this, why it works and why it doesn't work, and we can have a look at the documentation for that. I haven't time to do it all now, but you know, we would expect that to work, and why didn't it work? Okay, so worthwhile doing. I can come back to it and answer it again at a later point. Okay, so we're back to our working program again. Okay, so I guess what's happening here is that there's some information in here that allows us to be able to do this work and not do the work we want to be able to do. Okay, so I'm checking the time. We have to look at indexers. And thanks, Brian, for coming back to me. That's good. I'm glad I got that. Okay, so that's struts. Okay, and there are issues around accessibility and so forth with those, which you can get. And if you go back, sorry, I think I gave the link. Yep. So if you go back and have a look at this, you can have a look at some of the documentation and examples, and it will help. Okay, so let's move on. Okay, so we've only got about 25 minutes left. Okay, so indexers. So indexers allow an object to be indexed like an array. And there was a question early on about array lists and so forth. And I mentioned that we can have lists and then allow them to be indexed like an array. So this is an example, and that means they would actually have an indexer associated with them. So Microsoft refers to indexers as a syntactic convenience that allows you to be a class, a struct, or an interface that client applications can access as an array. So that's useful. So they're frequently implemented in types whose primary purpose is to encapsulate an internal collection or array. So it's like a record of your grade scores for different assignments taken in a module. Let's say we had something called a class called grades record, and that contained a grades array that was a type float to store the grades value. Then by having an indexer on that class, the client, and when we talk about clients, we mean other methods or applications or program, they can access the grades in this grade record instance using float, say grades CS264, as assigned a value of grade record 2, instead of actually doing float grade CS264. This is just a variable name. Grades.record dot grades 2 square brackets. So you can see we have this and this. So it allows us to be able to create this indexer on the class. Okay, so to declare an indexer on a class or struct, you use this. Okay, this. Okay. And you'll see what happened in the last exercise when I was looking at this here. This doesn't behave as you might expect if you're working with Java. Okay, that's the reason I did this. Okay, let's see what we got. Okay, so we use this keyword to make an indexer. Okay, okay, Sam, I see that. Yeah, probably because I didn't put the get. I didn't have time. Okay, I can go back and do that and check it. Thanks. Let me just go back. Oh, I won't go back. But yeah, that makes sense. Okay, so I was doing a setter and I probably only had the getter in that particular one. Okay, but okay, right. Thank you. Okay, so we use the this keyword to make the indexer. The type of the indexer and the type of the parameters must be at least be as accessible as the indexer itself. Okay, so then the signature of an indexer, that consists of the number and the types of its formal parameters, and it doesn't include the indexer type or the name of the formal parameters. Okay, so if you declare more than one indexer on the same class, you must have different signatures. So in other words, we're talking about overloading methods here. Okay, an indexer value, that's not classified as a variable, so you can't pass an indexer value as a reference or an out parameter. Okay, we'll see a little bit about reference parameters later in this lecture. And C# allows us to define custom indexers, generic indexers, all that stuff. You could try this yourself with both enumerations and struts. So let's have a look at the program. Okay, we see that there's a definition here. Public class grade record, as I mentioned already. We have an array of grades here, okay, called grades, and they're floating point numbers. And we can see we're assigning the values initially here. So we use the F, of course, because they're floats. Then we're able to look at creating a property, which is the grades.length. Now we look at the indexer definition. So we're actually using this index here. So this is the property here. Okay, so that indexer declaration allows us to be able to do something and create that index. Something interesting like create that index on this particular array. Okay, so so it looks good. So we set the property for the grades record, and we're able to return grades.index, or we're able to set the value that's passed to it as part of this as well. Okay, that's the passed value. So a lot of time if you're reading notes on this, you'll see that index definitions rely on this and value. Okay, you'll see a lot of those. Okay, so let's create a record, new grade record, and then we can access it here. Grade record 2, grade record 4. Okay, and that means that it's able to extract the grades. So we're hiding grades in many respects from the client. Okay, so we can have a look at this as well, I suppose. Shift tab. Where am I? Okay. And okay. We could change this, as Brian said, to make it set, and it would work for us. Set here, set here. Yeah, that would work too, of course. Thank you, Brian. Let's get rid of this one, and let's have a look at the next example. Indexers. Okay, this is the example that I worked with. There's a few extra ones as well, okay? So maybe I might go back to this, but it will work. Let's go back to the actual lecture, the slides. No, I just didn't talk any more about it. I just gave some examples of these things here, okay, in the class. So yeah, so we can go back then. Okay, so here was another example of using this. So let's say I had a collection. So now, I suppose in this particular one, we're going to use a string as an indexer value, okay? And this again is directly from the Microsoft documentation, and this one has one method, uses an expression. There's a nice exception handling here, which I really like. So we want to be careful of out of bounds. So let's say, for example, we asked for grades 20 or something, we would get an error. It's 10-dimensional array, so we would get an error. Okay, we want to be able to handle that. So here's, for example, a days collection. Okay, it's a class, and Sunday to Saturday, and we have an indexer with an accessor, again with the expression body definition here. So this time we're going to say this we index with a string, and we're able to assign a function here in this particular method here, find a day index with day. Okay, so it's a get only property. Again, this is a get only property, so we can use this operator. So here is my private function that returns an int with a string, and what it does is it's able to iterate and return the actual day associated with the string representation of the week. Notice, of course, that we have this argument out of range exception handling happening here, and then we're able to do that and get an error. So day is not supported, day input must be informed Sunday, Monday, etc., etc., etc. So it's nice because we got some nice exception handling in this particular one as well, which I like. Okay, so let's look at our example. Okay, so here was our grade record 4. We're able to do this, and that means we don't have to actually explicitly single out the we can use the class name. We don't have to single out the data in the variable that's the instance variable there. Okay, in here, so we didn't have to do grade record dot grades or whatever with an index. We're able to use the object name itself. So we can look at the data, and then we can look at the collections as well and have a look at the data. We can find out what the day of the week Friday is, depending on where you are in the world, whether you decide you want to count for Monday or Sunday. And then we're going to try this. So we have some made up day. We catch the exception and say that isn't supported. Okay, so that would be fine. Okay, so let's do this. Okay, so and we expected to be able to get this where we just printed the first 2 grades, and then we iterated over all we can iterate over all the grades. Okay, we overwriting the original data here, which was 195. Okay, and we can do that as well if we want, and we can now see that Friday was week 5, which is what we expected. Let's go back up to that particular one. 0, 1, 2, 3, 4, 5. That's what we expected, and we were able to throw the error then because this made-up day isn't an actual day name, and we get the error, and we're able to use the message that was created when we threw this exception here. So it's fairly straightforward to do and work with these. Okay, it's not too bad at all. Okay, if you have any questions, please put them into the chat there. Okay. Okay, let's go back to the notes. Okay. Yeah, and again, it's what's important to realize is that you can use these indexers on enumerations and structs as well. Okay. So the next thing we want to look at are generics. Okay, and Microsoft tells us again, in their notes, and I probably have some information on generics as well, so you can see there's some notes on the next slide. Generic types, we use generic types to maximize code reuse, type safety, and performance. And I guess with classes and structs, performance, as I mentioned earlier, is always important. But the most common use of generics is to create collection classes. So the .NET class library contains several generic collection classes in the systems.collections.generics namespace, and they should be used whenever possible instead of classes. So in other words, don't write your own, use the ones that are there. The only reason you want to write your own is that if you really want to understand how something works. So then let's look at how we do create it. So it's possible to create them. You can create generic interfaces, you can create generic classes and methods and events and delegates, which we might see a little bit later, but we haven't time to do that today. And generic classes can be constrained to enable access to methods on particular data types as well. So you can have constrained generic. I don't know why you want to do that, but you can. Okay. I can think of ways you might want to, but for now, let's just say you can't. So information on the types that are used in the generic data type can be obtained at runtime using reflection. We might see a little bit about this later as well in some detail. It's another advanced concept. I know you may have seen reflection in Java as well, so it's been able to to an object to be able to examine itself and understand itself. And sometimes you see that in conjunction with serialization and so forth. But again, it's all nice stuff. But in summary, generics allow you to write a class or method that can work with any data type. So that's nice. And I'll give you an example of a swap function a little bit later. So with generics then, okay, you write the specification for the class or the method with the substitute parameters for data types, or substitute type parameters. Okay. Okay, so we see this is one here in these angle brackets. Okay. So when the compiler encounters a constructor for the class or a function called for the method, it generates the code to handle that specific data type. So it's really nice to be able to have that. Okay. So we have a general structure of what the process looks like, and then we're able to just specify, dynamically generate, or the compiler dynamically generates the code to be able to do that work for you with that particular type. So if we think back to earlier, we talked about struts, and struts were really useful when we wanted to look at data structures that just had structure and didn't have much behavior. So the generics now tell us a little bit more about the behavior that will apply to general structures, okay, or general data types. So it's useful to have that distinction in your mind, okay? So a generic type may be declared by specifying a type parameter within angle brackets after the type name. So type name, angle brackets, T, where T is a type parameter, okay? And then we are able to refer to, so this kind of becomes a placeholder for the type. Okay, so it's a type, that's what a parameter is. It can be whatever type you give it at the time of calling. And then you don't have to use T, okay? It's whatever's inside these brackets. You call it bananas if you want it, it doesn't matter, It's not required to use T, but you see it a lot. But any valid name can be used as a type parameter. And then Microsoft have given a really nice linked list demo, for example, where they you can click through, I guess, here, where they don't use T at all, so that's fine. So let's have a look at this class. So let's create a generic class generic list called T. And this list has an add method that allows us to be able to add something. Okay, so whatever the input is, that's a variable. And that's the generic definition. It's very straightforward. Okay, so let's have a sample class then, just because we're going to need it a little bit later, and let's just test. So now we can say generic list int. So at the time of declaration of this variable here, this object here, we're telling it that it's going to be a list of ints. And we're saying a new generic list int. Okay. So in other words, the T up here, the type parameter is int. So wherever we see a T, we will essentially replace it with the type parameter. So this becomes an int. So C# compiler will create this constructor, this method to be able to do this with the int here. Okay? And then we can just add one, adding an int. We can also declare a list of a string here, and we're passing a string. And we had this example class earlier because we wanted to just create a sample class just to show what you could work with objects. So we can actually generate a generic list of classes or objects. Again, we're using an example class as the type, and we're just adding a new example class. So that's really really useful. You can see how it will work if we want to be able to build, collections of data structures or codes or classes that will work with lots of different types. So you don't want to be writing a linked list for strings, a linked list for ints, a linked list for objects, and so forth. You just want to write it once and then say, well, look, everything works the same. We just work and we just have different types, and that's what makes it generic. So a generic class can include generic fields, and they can't be initialized. Okay, so you can have, say, class data T, for example, public T data, but you can't actually say public T data is equal to new 10. So we can't create we can't assign a value to that. We can't say public T data is assigned a value of whatever 1, because, well, what's 1? That then it's not generic. We don't have a generic default value, so it makes sense we can't do this. You can create generic arrays, as I say, as well. But again, these can't be assigned data because we don't know what the type is at the time. You can have generic methods, and that's declared with the type parameters for its return type or parameters. And so, and again, generic methods can be overloaded. That's really useful to be able to do that. A non-generic class can also include generic methods by specifying a type parameter in the angle brackets with the method name. So you can do that. That's nice. And we look at a swap and a linked list example if you'd like. Have a look at the Microsoft linked list example. It's really good. Okay, and you can click through for all sorts of information on generics here as well in the documentation. Let's have a quick look at the program. So I'm interested in a simple generic called array store. And what this does is allows us to be able to store arrays of things. Okay, we don't say what the types are at the time, but we'll do it a little bit later. So then we could create a method called add or update, and what that does is it uses an index on the item of that particular type, and it adds the item. Okay, a little bit of testing here. You could do better work on testing as well for indexing. You could throw exceptions if you want, or you can just do it. Okay. Then we have another add or update. That add or update, if we just have an item that's passed instead of, it's overloaded method, so we have an index here, or we just have the item, then I've decided that this adds this item to every element in the array. But that's just to demonstrate the overloading that happens, generic method overloading. And we can, for example, we can get then return the data as well, okay? Or we can return the default value for an object. It's not a great data store example because it's fixed, only 10 items, and that's why array lists are useful, and array lists are a nice example of generics. So you could see that. So, but the point is just for the purposes, really, anything else. Okay, so let's have a quick look at the example that we have for this one here. Maybe it's my test, is it? My test? Okay. Okay, so this works here. And we shall see, does this work? Okay, yeah, I have a few things that I've run here. So some examples I've done. So this generates the list. We saw this generates the list. This adds something to the array store. So we had the array store. For example, that was the one we just saw a couple of minutes ago. Yep, array store is here. So it's fine. So let's go down through this and have a quick peek then at this code. So what I'm doing is I'm creating an array store of strings here, and I'm adding Charlotte and Emily, for example, adding updated, and I can write these and have a look. Then I have an array store for a float of grades. I'm adding some grades here, and I'm adding those as well. And then we can actually use the generic method in a non-generic class as well. So we can get the type of, for example, this doesn't make sense really, but yeah, we'll do it anyway. Okay, so we can actually get the type of this because I wrote a method here called get type of. Put it somewhere anyway. That method. Okay, so I had a method called get type of. It's in another application, I think, there. Pull this out. Where did I put that? There it is. Okay. So I produced this. I wanted to give you an example of how you could have a non-generic method using a generic type. Okay. So here I had a non-generic method. So it was pulling this, getting a type of here. Okay. And it was part of this class here. So I was just generating this. look at this example. So really it's a design flaw, okay? Because what it does is it gets a type of generic type parameter, okay? And then there's the complete opposite of the notion of using generics, okay? It's a counterexample in a way, okay? So you should use method overloading to do that. But anyway, we can get the type of the item if we want them printed to the display. So I wrote it. It's something you shouldn't do because it doesn't make sense if you understand generics. But I did it anyway, okay? But you can see that. But just to prove for ourselves that it works fine. So, you know, the array store is working fine there. And then we got the various types as well. So all of this stuff worked just nicely as well. We were able to look at string arrays, floats, and it's pretty good, you know. I like the generics. I mean, I think it works really well for us and the kind of data modeling we want to be able to do. Okay, I also had a swap function as well, I think. Let me see if I can get that for you. And this is nice. This is a nice example because you think in terms of what does swapping involve? Really, do you really need to know anything about the data types in order to be able to swap them? I don't think you do. Okay, so we have a program. Well, like if you think about swaps, okay, so swapping is that we have two variables. You want to swap the two variables. So in order to swap the two variables, we always introduce a temporary variable. So we create this temporary variable, and then so we move the left into the temporary, the right to the left, and the temporary into the right, and so forth. So you essentially cycle through these things here. Now, except in my favorite programming language, which is Perl, where you just want to swap A and B, you just do brackets A comma B bracket is equal to bracket B comma A bracket, so you don't have to introduce that temporary variable at all. But then Perl is cool, right? So for that kind of stuff, and it's good because Perl programmers tend to be a bit lazy. But okay, so you do a bit more work here in this particular language, of course, but and it's much more versatile, C#. Okay, but really swapping is fairly straightforward. So swapping allows us to be able to take the left and the right term and we swap them, okay? So we create this temporary variable of the type variable that's necessary type parameter. Temp is left, left is right, right is temp, and it works for us. So this will work for any type. It's really nice as long as we want to swap to do that. Notice we're passing by reference here. So we're not passing by value, we're passing by reference. So we're actually want to be able to, we want the values of of the left and right to be changed after we call the swap function. Okay, we're not just taking the value, we're actually getting a reference to the value. I don't know if you've done this kind of thing before. Maybe you might let me know if you have or haven't, because we could do that. I could go over that again at some other point for you, please. Okay, so here's some variables, X and Y, here's some strings, hello world. And we can do the before and after, and we can do the swap on ints, swaps on strings, and it's really, and we're explicitly saying that we want to pass the reference, not the value here. Otherwise, they would never be able to change them, okay? Because you can't change the value of a value, okay? It only exists as a literal. So, but we can change the value or the contents of a variable if we pass the variable. And a lot of the time when we pass, by default, we pass by value rather than pass by reference. Okay, so let's run it and see what happens. And it should behave exactly as we expect. So it's not surprising there. We can see that. The before and after, we got the swaps. Okay. Right, okay, so that's generics. They're good, you know, and you'll see a lot of them. If you look at the linked list example on Microsoft, it's a really good one as well. Okay. The final piece that we're going to look at today is collections. And so typically you want to manage groups of related objects in your programs. Two ways to achieve that: creating arrays of objects, creating collections of objects. And we talked about arrays, so let's talk about collections. So collections provide this flexible way to work with groups. And with collections, the group of objects can grow and shrink dynamically depending on the application requirements. For certain collections, you can assign a key to an object, insert it into the collection for later retrieval using the key, say hash tables, key value pairings, all that kind of stuff we did in CS230. In C#, if your collection contains elements of only one data type, then you can use one of the classes in the built-in systems.collections.generic namespace, and a generic collection enforces type safety. No other data type can be added to the collection. It's really useful. And when you retrieve an element from a generic connection, you don't have to determine the data type or convert it or any of that kind of stuff. So some examples would be array list, as somebody mentioned earlier. It's an alternative to an array, and you probably used it already and seen it for your assignments. You can add and remove items from the list, specify position, using an index of the array, then resizes itself automatically, but it also allows you to be able to actually use it as a list. So add, and you can also have a sorted list. There's also a list class. We have hash tables that use a key to access elements in the collection, and that's used when you need to access elements using a key to select the value. Okay, so in other words, key value pairings. Stack, of course, is a LIFO structure. You know, when you want to last in, first out access to items, you can push an item onto the stack and you can pop it off, and then queue, that's a first in or first out, a FIFO access to items. Add an item to the list, it's called an enqueue, and when you remove it, it's called a dequeue. If you can check the demo here in the collections on Microsoft, you'll see that. And I'll do a little bit more of that later in the next class. I think let me just check just to be sure that we have this, and I think I produced a collections as well. I don't have time to go through it just now, but you can look and run that program yourself, okay? And it's an example, very simple example. But that's I think that's everything, okay? So we can't do all of the advanced stuff in just an hour and then go into it in any detail as well. But it's just some of the advanced features of the programming language, and there's some, you know, it's all around managing data or behavior and generality, indexers, iterating over the data, finding and manipulating the data. That's it. We'll cover some of the link in the next class, and I'll probably try to do some more in-depth demos of the collections, but there's lots of examples of them there, and I'm sure you've seen some already. Okay, thank you very much for attending, and I'll see you in the next one. Okay, thank you. Have a good day.